Okay, I've started the recording. I'll share the screen. All right. So good evening and welcome to the 10th session for the NPTEL course Foundations of Our Software. And yeah, so we've had 9 sessions so far. This is the 10th one and there'll be 2 more. Also, most likely we would have a revision session as well. I've not noted this here, but it should be on the 21st of October, right before the exam for this course. So in case any of you would still have any questions or any doubts or any final things to clear up, we can have that as well. Before we start this week's session, do you have any questions?
I am using the R version 4.4.1.
Uh-huh.
I am not getting that grep1 function, madam. grep1.
GREP in R 4.4.1.
Yes.
Okay. Can you share your screen maybe and then we can take a look at that? You want to share your screen now?
1 minute.
Okay. So just in case anybody is not aware, so this is one of the functions we'll be talking about in this week. So I'll be giving
1
you
minute.
a brief of that function in today's class. But just before we start, let's take a look at what's happening. Are you getting the option to share the screen? Natrajan, are you getting the option to share the screen? Okay. Yes. I can't hear you. Yes, I can see your screen now. Yes.
Yes, madam.
Yes, you can start typing. You can type GREP in this.
Yes, madam.
Put the curved brackets and then press enter. Is this L that you've typed, right? This is L, right? Not 1.
1 minute.
No, this is L.
1 minute.
You've typed L, right?
No, 1, madam. Just
No,
now
no, this
one
is,
type.
no, there is L. It's the letter L.
grep. I am
Rep
typing.
L.
You want to type L or 1?
L. Type L.
Acha. It's
Yeah.
not grep1.
No, it's not grep 1, it's grep L.
Okay.
Yes, all right. Okay, cool.
Okay, another question, madam, regarding that one assignment question, how to find that class from the painter variable. Schools, there was some question, I'm not getting that also. How to find the
Okay.
class?
Okay.
You can explain, madam.
We'll take a look at that at the end of this class. All right.
Okay, okay, madam.
Let's maybe while having the revision, you might get the idea already, and then we can
Okay,
explore it
okay,
at the
madam.
end. All right.
Shall I
Yes, you
close
can.
the sharing, madam?
Yes, you can
Thank
stop
you.
the sharing. All right. Thank you.
Thank you. Thank you.
Okay, I'll reshare my screen. Okay. So basically in week 10, there'll be two things that we're going to talk about. One is about finding patterns in some sort of an input, and the other thing is going to be making data frames. So we'll start with the first thing first. So let's take a simple example. So I'm defining the variable a. It's just a simple character value. It's a simple character value, and that this is NPTEL NOC24-ma95. Now, there's this function sub, which is short for substitute. And what I'm basically saying, so there are going to be three inputs in this command. The first input is what you want to find. The second input is what you want to replace it with. And the third input is where. So basically, I'm saying that in my input A, you find wherever IS is written and replace it with the capital IS. Okay, now here it's going to substitute just the first occurrence of IS. Whereas instead of the SUB function, if you write G sub, it's going to replace all occurrences. Give me 1 second. I have a little scratchy throat today, so you'll have to excuse me for that. Okay, so the first function is sub and the other function is G sub, which stands for substitute and global substitute. So what's going to happen is for the first function, the first occurrence of IS is this. And this is the second occurrence of IS. So the first function is only going to replace the first occurrence and the second function is going to replace all occurrences. So if I execute line number 8 and 9 here, so you can see in line number 8, only this got changed to a uppercase, and in the other one, both got changed to the uppercase, right? So what this function did is that it found something and it replaced it with something. So, so this is replacing, whether it's the first occurrence or you want to globally replace something. Okay. The second function we'll talk about is grep, which stands for global regular expression print. Now, this is just to find a pattern. It's not replacing anything. We just want to find where it is. So let's say we are talking about this vector here. Let's execute this and see. So it's a 7-element character vector. And these are just random words I've made. Let's say if we want to find, again, if you want to find IS in this one. So you can see here that there is this word where IS is. This word also has IS. This word also has IS, right? So there can be different ways in which you may want to obtain where the IS is. One way can be you want R to output the index of where this word is, right? So out of this vector, I can say that okay, the third element, the fourth element, and the fifth element that has IS. So tell me 3, 4, and 5. Or I may want to find the actual word where this is. So you should output this, his, and is. Or I want you to output in terms of true and false. That it's false, false, true, 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 false, false. Right? So there are 3 different ways in which you still get the same, you can still make sense of that answer. So the first way is simply writing grep, and in double quotes, you want to type what you want to find, and the second argument is going to be where you want to find, right? So same as sub, but there's no replacement here. There's no this middle argument. So there's 2 arguments, simple. So if I just run this directly, it's going to give me 3, 4, and 5. So this is giving me the index. If I write value is equal to true, then it's going to tell me the value. It's going to tell me what that element is at that position. So you can imagine that the value is false by default, but When you have explicitly specified that the value is true, then it gives you the value. And this one, the grep L thing. So the L here actually stands for logical, right? And if you know, true and false are logical words in R. So if you type grep L, but the same thing inside is in B, then what you get is a set of true and false. So at indices 3, 4, and 5, you get true, but everything else is false. There is one more way in which, even without saying value true, you can still find what the value is. So you see this one, the one that I've highlighted, which is same as line number 15, that's giving you indices, right? It's giving me 3, 4, and 5. And we know that whenever we are talking about a vector, and if inside I'm writing another vector, which is a set of indices, right? Let's say 3, 4, and 5, then that's what I'm going to get, whatever the values are. So if I simply write something like this, B, and then square bracket, which is for me to specify where the indices are. And then inside, if I'm going to write these indices, which I get from the grep command. So then this directly is going to give me the output. So basically, what I'm trying to say here is that line number 16 and line number 17, they both give you the value. Whichever one you prefer more, it's up to you. Okay, there are a few more arguments. So value we have already seen here. So arguments, you also have ignore case. So imagine if here, if you would have had something like this, right? Maybe something like this. So whether you want only short, like lowercase is to be considered, or lower and uppercase both to be considered, then you can write that ignore case true. So it's not going to ignore, it's going to ignore the case. It's not going to consider whether something is small I or capital S. And if you say ignore case is false, then it would take care of the case. So it'll say that, okay, whatever you have input, if you've input small, it will only match it with small. If you've input capital, it will only match with capital. So that you can, so by default, um, you can, it's up to you which one you want. Okay, any questions for these two commands, or is this clear so far?
Okay, madam. Clear.
All right, okay, cool. Then now generally, when you want to find something, it may not necessarily be that you want to find some exact match. Sometimes, like in this case, we are exactly saying finding, you want to find is, right? But let's say in some case, you may want to find a pattern. Okay, so that is, in terms of, in the coding language, it's often called a regular expression, or regex. So there are different ways in which you can specify a pattern. These are some of the most commonly used patterns, but there's a lot more, but they are more complicated. So there's no point in discussing those at the moment, but we'll take a look at some of these examples right now. So when you want to find any number of characters, and it could be any characters and any number of characters, then you write an asterisk. And if you want to find any letter, but just a single letter, then you use this dot or full stop. And if you're interested at the beginning of some input, then you use this caret symbol. If you're interested at the end of the word, you use the dollar sign. And when you're interested in a particular range, now that range can be numbers or alphabets. So we'll take some examples. So when you're talking about a range, you'll be specifying the range in a square bracket and separated by a hyphen. So let's just see examples for all of these. Okay, so again, the example for this one is still going to be the vector B here. So this is that vector B, right? You have these random set of words. Now, if I ask you, so let's take it step by step. If I ask you that we want to find words which start with H. Okay, so basically you want to find hello, hi, and his. Okay, so these three. Can you think what we might do out of these options? Which one would work the best? It's just a guess. You can guess the answer. That should be okay. Do any of you want to try this? Okay. If not, so the so we've seen how grep works, right? The first argument is going to be what you want to find, and the second argument is where you want to find it, and you can specify value is true to get that value. So what I'm going to do is I'll just say caret h. So this would mean whichever words begin with an h. So if I run this, I'll get these three as the output. Similarly, so in this case, we were finding is. So it's giving me all of these words, right? But if I just write caret is, then it would only give me is, because that's the only word which is starting with is, right? Likewise, if you want to find words which end in a particular letter, then I'm going to write that letter followed by end symbol, so which is the dollar symbol in R. So if I do that, then you get a set of all the words which end with an S. Okay, now let's say if you want to find words where there is an H, there is an S, but between the two, there is some letter. It could be any letter. Okay, so I'll specify that with a dot. And if I run that, then I get these three words, because here between H and S, there is a single letter. It doesn't matter what that letter is. And if I want to find, if I want to find words where H and S are separated by one or more letters, so which basically means any number of letters, any number of letters, then I'll write this. So dot means anything, and asterisk means any number of times. So dot asterisk together symbolizes any number of letters, any letter and any number of times. So if I do that, then in addition to these three, I also get thanks here, because their H and S they are separated by multiple letters. Okay. And another way to do an exact match can be that, suppose you just want to find is. So you're saying that it begins with is and it ends in is. So beginning is given by the caret symbol and end by the dollar symbol. So if you run that, it will just give you is exactly. Right? And then when we were talking about ranges, so let's go to line number 47 for now. So let's say you want to find words which only have characters between N and Z. So if I run this, mm, yeah, I think, okay, this has that it has at least one letter which is between N and Z. So I think, yeah, it did not return one of the words. I think, yeah, it did not return high, because high has both the letters before, like none of the letters are between N and Z here, right? Likewise, if you have numbers that you're talking about, so out of this vector, which has numbers between, so it has 1, 2, 5, 6, 8, and 10. If you want to find numbers which are only between 2 and 9, inclusive of 2 and 9. So if I run this, then it has removed 1 and it has removed 10 also here. But you will see that it's converted this into a character, because grep by default, it will identify numbers, but it will consider them, the output is still going to be considered as a number. All right. So in this case, this is where this sort of a thing might be useful. Once you've got the indices, you're obtaining the values from the actual vector rather than asking grep to return you the value, right? Because if you do this, then you would still get numbers rather than characters. All right. Any questions up till this point? Okay. If there are no questions, so then we'll move to the second part of what was covered this week. So now we'll be talking about a new sort of variable in R, and we'll call it the data frame. So one of the basic advantages of, so it's still a two-dimensional arrangement, so it looks very similar to a matrix. There are rows and columns. But the major advantage over of a data frame over a matrix is that in matrix you could have all the elements of the same type. If one column is a character, the other columns also have to be characters. You can't have one numeric type or one factor or one something else. But in data frame, each column can be its own data type, right? So because see, some very common example of, let's say you take an Excel file which has, let's say, student informations, right? You have serial numbers, roll numbers, names, addresses, phone numbers. So some of them are going to be characters, some of them are going to be numbers. If they're divided into some teams, those teams can be called as factors, right? So you can have different data types in different columns. So that's one of the advantages. And the second advantage is we can use this dollar symbol to access columns, which is also something we saw when we were talking about named lists. So basically, in a data frame which has multiple groups or categories, and if these categories are named, you can access them using the dollar symbol. And in case of data frames, these categories are actually columns. Okay, so we'll take some inbuilt data sets of R as an example for today's class. Okay, so to take a look at what data types, what data frames are available in R, I've just typed in data and curved brackets, and it gives me these data frames which are already there in R. These are data sets that are available within R, so we can directly use them. So you can see on the left, you can see the name of these data frames, and on the right, there's a very short description of what it's telling you. So we will be first taking a look at the iris database. This one. So iris. So these are some flowers and flowering species and their petal length, petal width, sepal length, sepal width. So it's a very simple data set, and we'll start off with that. So just to take a look, I'll type in iris here. And if you want to take a look, so we'll type in view with a capital V here. And okay, give me 1 second. Okay, so we'll start off with this iris database. So you can see here there are 5 columns. Sepal length, sepal width, petal width, and the species. And so here, if you've opened this as a view function in R, you can see that it's showing you that there are 5 total columns and there are 150 entries in this, which is to symbolize that there are 150 rows in this. Okay, but let's still see what typically when you get a data frame, you would like to know a little bit about it. So what we can start off is seeing what dimensions it has. So if I write dim and the name of the database, so it says 150 and 5. And again, 150, the first thing is always rows, and the second thing is columns. So it has 150 rows and 5 columns. There's one more thing which is good to know. That's the structure. So str. And if I say iris, then it says that it's a data frame, 150 observations of 5 variables. And you can see how before each of these variables, you have a dollar symbol. So sepal length, sepal width, and these 5 things, where the first 4 are numbers. And the last one, species, it's a factor, which has 3 levels. Okay. Okay. So a data frame can have row names and column names. Now, definitely, you should have names of the columns, right? So these 5 things that we just saw, these are column names. But whether a data frame has row names or not, it depends. Very often, you may not need row names because very often these numbers, the row numbers itself, the indices of the rows, so row indices are always going to be numbers, right? They're going to be 1, 2, 3, 4 up till, let's say, 150 here. If a user has not explicitly specified the row names, then these numbers will become row names as characters. So number 1 will become character 1. So number 10 is going to become character 10 and so on. So that is something you can see here. When I've typed row names of iris, it's giving me these numbers, but within double quotes, which is saying that these numbers have been converted into characters. Because, well, names are going to be characters, right? So row names, that's character. Okay. And then we've seen commands like this where is dot character, is dot number, is dot matrix. So there's a is dot data dot frame also. And if we run this, it's going to give us true. All right. Now, since a data frame is very similar to a matrix, accessing elements are also going to work similarly. So you'll have square brackets, and there's going to be 2 numbers, one before the comma, one after the comma. The number before is going to indicate row or rows, and the one after the comma is for columns. So again, can you tell me what would this give you? Line number 67, what would this give you? Which element? Do you want to give a try? Okay. So this one here is going to be first row and third column, right? So if you're talking about here, this is the first row and this is the third column. So it should give us 1.4 as the output, and that's what it does. And if I'm specifying multiple rows and multiple columns, then it would give me a smaller data frame, right? So very often this is also called subsetting, and we'll see more about subsetting in the next class. But making a shorter data frame, whether it's in terms of columns or in terms of rows, that's subsetting. So you can see here, this gave us the first 10 rows and just the third, fourth, and fifth columns. And this one here would obviously give us first row, all the columns. This one is going to be all the rows for the first column. And now, like we have talked about, columns is how, so each column is an independent variable in a sense, right? So when you're just taking columns here, its default arrangement is that of a vector. But again, both 69 and 70, both of these lines, they're giving us a one-dimensional thing. It's just intrinsically R handles this as still as a data frame, and this one it handles as a vector. But both of them are one-dimensional values. All right. And again, when you want to access a column, so there are going to be these 3 ways, just like we had seen in the case of list as well. One is you specify the vectors, one is you specify the position of that column. So here it was the third column. Second thing is you can specify the name of that column. So that's going to be in double quotes. So let's say it was petal.length. But of course, here you have to be very careful that you have the uppercase and lowercase thing all correct. And the third thing, which is the most important application of data frame, is you can specify this using, if you write the name of the data frame and then you write the dollar symbol, R is automatically going to give you these options, that what all options you have, and then you can just select whichever one it is, and then you don't exactly need to remember what the exact spelling is. But nevertheless, all these three would give you the same answer. So if we run this, you see, you've got the same answer. Okay. And of course, you can specify more than one columns. Um, in this case, we have two columns, all the rows, but using the dollar symbol, you will not be able to specify more than one column, that's for sure. But using either just the indices of the column or the names of the column, you can get a smaller data frame. Okay. So let's say now we are making a smaller data frame with just rows 50 to 59 of the IRIS database, the IRIS data set, and all of its columns. So for that, this is what we'll write. For rows, we'll write 50 to 59. And for columns, I'll just leave it blank. So it would imply it's all the columns. So I'm saying iris, square bracket and this thing. And then we save it as iris underscore sub. So here you can see that now you have a smaller data frame here, which says you just have 10 rows, so 10 observations of 5 variables. Now, one thing important to note here is that you see these numbers on the left. Now, these numbers are not indices because see, this one is still the first row, second row, third row, and so on. However, this 50, which came from the old data frame, this 50 is actually the row names, right? So if I write here row names of iris underscore sub, if I run this, so you see these are the row names. But of course, row indices still be 1, 2, 3 until 10, right? Because if I write iris underscore sub and I write 1 here, I'll get this. If I write 50 in double quotes, I'll again get the same thing. But if I write 50, just if I write 50, it's going to give me NA because there is no 50th row. There is a row with a 50 row name, but there's no row which has 50 as the index. So this is sort of meant to confuse you, but just keep this in mind. Okay. Okay. Are we clear so far?
Yes, ma'am.
Great. So next up, we can check each of the columns here and, let's say you want to see if something is dot numerics or petal length. Yes. Is petal dot length character? It'll give false. So this structure thing we have already seen so far. If we say summary, so summary is a nice function, and whether you apply it to a particular column or you apply it to the whole data frame, it's going to give you slightly different outputs, but let's see what this is. So when I'm giving it on a particular column, so what it's going to give me, it's going to give me the minimum. It's going to give me what the maximum value is. It's going to give me where the first quarter and the third quarter is. So if you remember, so you can have like so except the minimum and maximum position, you can divide it using three values, right? The 1/4 value, the half value, and the 3/4 value. So this is what this is. The first quarter is that 1/4 value. Third quarter is 3/4 value. Median is that halfway positional value. And mean is, of course, the arithmetic mean or the average. So when you're talking about numbers, you'll get this for your summary. And if you have instead factors, so let's say, for example, for species, it's just going to give me how much of each is. And if you give summary for the whole data set, then it's going to give you all the values for all the columns. So I mean, that's just everything altogether. Okay, so this is about dealing with an already built data frame.
That
Now, I
median
think,
means it is taking equal values on left and right hand side.
say that again.
Median means if we're taking both the number of values, both left and equal right hand side equal.
Yep. Yes. So if you arrange your values ascending or descending order, so you'll have minimum, you'll have a maximum, and you'll have a middle value, and then you'll have the 1/4 in that order, and then you'll have a 3/4 in that order. So that's how the quarters are divided. It's often called
Okay.
like the quantile system, right? That's the same thing. So it's first quarter or the first quantile, anything. Okay. Um, so then we'll talk about making a data frame. And again, another just what you need to remember is you specify things column wise. Okay. So the simplest way is, so you write, so we'll start off by writing data dot frame, and we'll put a curved bracket, and then we'll specify col1. Now col1, the entire column. So for example, this one, that's a set of values again. So it's a vector. So you need to specify, let's say, the only important thing you have to remember here is that each of your vectors, so each of your columns should have the same number of elements, right? Because each column and each column should have each row. They can have any values here and there, but when you're specifying, the length of each of your vectors should be the same. So I'll just write, let's say col, and then I'll write a vector. So let's say I want to write A, then B, and then C, and then D. And then I come out of the inner bracket, I write comma, and then I'm going to write col2. And then I'll write, let's say I'll say rep 5, and I want to repeat it 4 times. And let's say that's it. If this is all I want to do. So I'll just press Control Enter, and then you see what happened here. I got col1 and col2 as my 2 columns, and the first column has ABCD, and the next column just has 5 as each of the entries. Now, this one is just one step ahead, where I have another column, and I have specified that my factor, that this vector, which is the 4 seasons, write it as a factor. So again, if I just run this and I open df1, so it says 4 observations of 3 variables, and this is what it looks like, right? So you can understand what's happening here. Okay. And I can of course write structure df1. So we have characters, we have numbers, and we have factors. So we have all 3 basic, these are the 3 data types you'll mostly be working with. All right, now we can make it a little more complicated, and let's introduce some changes here.
Column number 3, what is the 3241, madam?
Oh, this thing. Okay, so if you remember from the discussion on factors, if you're not specifying what are the levels of the factors, it arranges them alphabetically, right? So if I arrange these 4 words alphabetically, so you'll first have rainy, and then so after that it's going to be spring, I think, and then there's going to be summer, and then there's going to be winter, right? So basically, rain would get the first index, spring is going to get the second index, summer will get the third index, and winter will get the fourth index. Not index per se, but level. So this is the levels that it's going to get. So since you've specified summer first, so it'll write 3. Then for spring, it's going to write 2. Then for winters, it's going to write 4. And then for rain, it's going to write 1. Okay. Yeah. Cool. But good observation. All right. Okay. So now this is what ideally your data frame, this is mostly how you would specify. And here I've just put these things in different lines so that it's more clear and it makes more sense. But obviously you can have all of this in one line like we had here. Okay. So this is just to make it more clear, but that's all. Okay. So now here again, I'm doing the same thing. I'm saying call 1, same things. Call 2, I'm saying that repeat 5 twice. But you remember from our earlier discussions that since this is going to be repeated twice and since the total thing is 4 and 4 is a multiple of 2, so this can just be repeated again, right? So it will not be a problem. And then for the third column, I did not give a column name, right? So let's see what it does. And then for the fourth column, I'm not really giving it a column, but what I'm doing is I'm giving it this matrix. Now let's just take a moment and see what this matrix looks like. So I'll just write this here. And so you see what this matrix is. It's a 2-column matrix with 4 rows. So now if I'll just try to draw this out in PowerPoint. Okay, so this is where we are right now. Sorry. Okay, so I specified the first call. So call 1 is A, B, C, D. So this is easy, right? Then for call 2, I said write 5 and 5 because rep twice, but it is going to repeat it again because 4 is a multiple of 2. So this is how it's going to appear. Then for call 3, I did not give it any name, but what I did give, I said 6, 7, 2, 8. Okay, so I said 6, 7, 2, 8. So we'll see what is happening here. And then instead of fourth column, I actually gave it a matrix, which is 1, 2, 3, 4, 5, 6, 7, 8. So again, I don't know what's happening here though, right? So I would assume my data frame is going to look something like this. So which has 5 columns and 4 rows. I should say 4 rows and 5 columns. Okay. So would you like to give a try and suggest what might these... So first of all, do you think R is going to do it this way or R is going to create some problem? Would it give some warning? Would it say not possible, error? What do you
It
think?
gives some error.
It will give some error? Okay. So let's see. All right. So I'm going to run this. And now you see it's run without any error, right? And here it does say that there are 4 observations of 5 variables. So it does seem like it's worked. So what it does, so now you see here, okay, ignore this thing for now. So let's say I'll write it by row is false, just for similar thing. Sorry. So this is what my new data frame is looking like. So it's worked the way we wanted it. Now what column names it's given it. So you see here this vector. This was actually the vector that we specified here, right? So it gave this vector as the name. So 6 c dot 6 dot 7 dot 8 dot 8, like 2 dot 8 dot something. I'm not very sure how it makes this thing up, but whatever it did, it made this as the column name. Now, of course, this is very, very complicated, but nevertheless, there is a column name. And for matrix, so if I just view this matrix directly, so you see, normally the matrix has V1, V2 as it's just specified. These are not names. V1, V2 is not the name of the matrix, but it's just there like a placeholder. But for data frame, however R internally understands it, it's given a default x1, x2. Anyway, so it does work, right? So we can change column names now because, of course, these names are very hard to, sorry, not this. So these names are obviously very hard to remember. So what we can do, we'll change these column names. So first of all, how to, so we've seen this a little bit in, I think, last week, but we'll take a look at it again. So the way to access column names and the way to specify column names, it's the same way, okay? So when you want to access, you'll say call names and you write the name of the data frame. So I'll say call names and in bracket I write df2. So it's given me that there are 5 column names. This is what they are. And if I want to change, I'll just assign something to it. So this is what I'm going to assign to this thing. So I'll make a new vector. Now this new vector has to be the same length, right? Obviously. So let's say my new vector is ABCDE, and I'm saying this vector is assigned using this symbol. It's assigned to the call names of DF2. So if I run this, and now if I open DF2, I get this new call names. And suppose I just wanted to change one of these, right? So I'll just write, let's say I want to change the third call name. So I'll write call names of DF2 and the third of it. So the third is by this square bracket 3, and I'll just write call 3. So if I run this, and now if I open DF2, it's just going to change whatever I wanted it to change. I can do it for 2 at a time, 3 at a time, all of them at a time, whatever. Okay. Now, so again, this example, it's very similar to what we just saw. The first column has 3 rows. The second column has just 2 rows, but of course it can be doubled. The third column again has 4 rows. This one again has 4 rows. But this one here, it just has 3 rows. And now if I run this, it's going to say arguments imply differing number of rows. So some of them have 4, some of them have 2, some of them have 3. Now mainly 3 is the problem. So R does understand that 2 is also there somewhere. But in the original case, it was not even throwing a warning. So again, cases like this, you really have to be careful with. But nevertheless, when it's not a multiple of the largest number, I mean, yeah, when not all of the rows are multiples of each other, R is going to give you an error. Okay. I think this is one. Okay, there are just a few more things, but I think we're pretty much on time. Do you have any questions up till here? We just have very few things left.
No, no, no.
All right, all right. Okay. Now, we've not seen a lot of examples today, but very often, so the main advantage of using a data frame is very often doing this dollar symbol. Okay, whenever you want to access columns, and for whatever you want to make some plots, you want to filter out some values, you'll always be using the dollar symbol. And very often you are overusing the dollar symbol. So basically this thing that I've highlighted. So you can already see that in these lines, the iris dollar is repeated. So sometimes what people do is they sort of tell R that, you sort of try to understand that I have explicitly, um, you know, specified that assume that iris dollar is written at the end, at the beginning of everything. So that's known as attaching something. So we'll just see some examples and then it'll be clear. So let's say again, functions like this, right? You just want to find minimum of, let's say you want to find the minimum of each of the columns. Okay, so I'll come to line 133 in a minute. But let's say what I'm doing is I'm saying attach iris. Okay, if I've attached iris, you don't really see any difference here. But now, if instead of writing, I mean, I can obviously write iris dollar sepal length. R understands that. But if I just write minimum sepal length, then also R can do it. Because it's sort of, when I said attach iris, it's going to attach iris to the beginning of everything. So it's saying almost everything. I say min sepal length, it works. Max petal length, it works. Unique species, it works. Right? If I just write sepal length like this, it's going to work. But now, what if I write? So right now, I mean, okay, so as such, the iris database is not in your global environment because it's there in R itself. But even when I've attached iris here, you don't see the column names appearing in the environment, right? Sepal length, petal length, sepal width, species, none of them are here. They're still just columns of the iris database. But what if I explicitly, instead of calling something ABCD, what if I'm calling something sepal.width? Then it's going to come in my global environment. Okay, fine. Now if I've attached iris and if I just write sepal width, okay, then it's going to give me this thing now. It doesn't care about the iris dollar sepal width anymore. That is what I would have wanted. But this value here, it has overwritten the iris dollar sepal width. I mean, I can still write iris dollar sepal width, but I've already attached iris. And by writing sepal width, it should have given me that column, but it did not, right? So all in all, uh, while the attach thing is important, I mean, it's useful a lot of times when you are repeatedly just using one data frame, but you should be careful that the columns of that data frame do not appear as any other variable in your environment. So anyway, once you're done with that database, once you do not want um, to attach it, you can simply detach it. And it's important that you do this so that anything that you write after this is not, again, there's no conflicts after this. So you just detach iris and then everything returns back to normal. So now if you're going to write minimum of sepal length, it's going to say that sepal length was not found because, well, of course, sepal length, there is nothing like sepal length in your environment, right? Okay. Does this make sense?
Yes, ma'am.
All right, perfect. Great. Okay. So we'll talk about subsetting now. So there is a subset function in R. So subset. And this function, what it does, it's that it's going to give you some rows, but all the columns. So it's just important to remember this so that when you're applying it, like you know when to apply this. When you're interested in all columns, but just some rows. So for example, let's say we are taking this iris data set, and let's say very often a question will be, can you tell me how many flowers are there which have a petal length which is more than 1.5, whatever this unit is. Let's say it's or centimeter, I think it's centimeters. So how many flowers are there where the length of the petals is 1.5 centimeter or more? So you want to find out all those rows, right? I mean, you don't really care about the columns, but mainly you want to remove rows which do not satisfy this criteria. So that's where you would get some rows and all the columns. So that's one classic example of where you want to subset. Or you may want to subset and just get the Setosa species, or just the Virginica species, or just the versicolor species, something like that. Or there could be more complicated cases where you want to say, give me an example of how many flowers, how many entries are there in this data frame, where the sepal length is between 5 and 6 centimeters and the petal length is between 3 and 4 centimeters, right? So you will have to combine two cases. So this valid and this valid. So we'll take those examples now. So take a look at the right side. That's where we are mainly specifying the command. And on the left side, we are just saving that into a new data frame. So the syntax of the subset command looks like this. So we'll have subset, curve bracket. The first thing you'll write is the name of the data frame. So we'll have iris in our case. And then you have comma. And after this, you have to write the condition. Okay. Now, this condition can be a simple condition or this can be a complicated one. So we'll see all of those now. So one of the simplest ones that we see here is this. So here, once you've written iris here, now you just need to write the column name. You don't need to specify a dollar symbol between these two things. So it just means within the iris data frame, take the species column and match it and see if it's equal to setosa. So you remember from our very initial discussions in I think week 2 or 3, when you want to find out these relational statements, you can have a double is equal to, you can have a greater than, less than, greater than equal to, less than equal to, or not equal to, things like that, right? So, um, so one of these, so basically this line number 153 here is saying that in the iris data frame, wherever the species column, wherever the entry is equal to setosa, you give me all of those. So if I run this and I save it as iris underscore setosa. So I get 50 observations of 5 variables, and you see all of these are setosa, right? Now again, this one here, what it's doing is giving you wherever the petal width is more than 2. Okay. So if I run this, this is this large. So it's 23 observations. So all of these are where the petal width here, this one is more than 2. So you can see this is more than 2 everywhere. Now, see, you can see here that it's all from the Virginica species because probably it's a bigger flower. Okay, so that happens. And then when you want to specify another condition, that petal width should be greater than 2 and sepal width should be greater than 3.5. So now you see the placement here. You have the iris data frame, comma, and then after the comma, you just have one statement. And so there are two sub statements, sub conditions, and they are joined together with this ampersand. So when you run this here and you get this, okay, so you get this question mark. This is basic just for formatting errors. I mean, if you run this again, I don't know why it's still giving this weird question mark thing here. I've never seen this. I don't know. Art behaves this way sometimes, but don't worry about it. So you can see here what happens here, that we did that petal width has to be greater than 2 and sepal width has to be greater than 3.5. So you just got the biggest flower entries here. Okay, now let's, I just want to introduce one more thing to you. This is not super important, but it would just give you another way of subsetting something. It's up to you which of the two ways you prefer. Sometimes you may prefer the one we just discussed, and sometimes you may prefer the one we are going to discuss now. Okay, so what we are going to do is we subsetted this one, right? We just wrote a very simple function, subset the iris data frame and species is equal to setosa. Now we'll do it in one more way. So if I just write this thing, line 158, if I just specify iris underscore species, so we've seen that each column is like a vector, right? If I just write this one, it's going to give me a 150 element long vector. And intrinsically, this is a factor vector. So it's going to give me these 3 levels also. All right. Now, if I specify this line here, iris underscore species is equal to setosa, we've seen earlier that what it does, it's going to give me a true false thing. So it's going to give me a vector true false with a length which is equal to 150. So if I run this line, you see, I got this 150 element big true false, right? This whole thing. Sorry. Okay. Now if I do this thing here, so basically, when I'm writing the iris database, data frame, iris data frame, and I'm writing square brackets here, I'm going to specify some elements, right? I put a comma. After the comma, I'm not putting anything. So which means I want all columns. And before the comma, I'm giving a true false vector, which has a length of 150. Now, what this is going to do is, it's going to give me all the rows which correspond to true. Like wherever true is, it's going to give me those rows, right? So when I did this, so it's going to give me all the rows. Sorry, it's going to give me whatever rows, wherever there is true, and it's going to give me all the columns. So again, I get a small data frame with some rows, all columns. And I save this also. So I'm saving two things here. Like I'm saving this as iris setosa 2. Now you see the original iris setosa, which we did using this line, and the other one, which we did using a similarly long, maybe it looks a little more complicated, but again, similar thing. Both of them give me 50 observations of 5 values, 50 observations of 5 variables. So if you compare both of these, okay, these look pretty similar to me. But of course, if you want to actually compare them, so there's a function in R which is identical, and I can just write identical, first one and second thing, like whatever two things I want to compare. If I run this, R gives me true. So what this means is both of these ways, they're correct, right? So line number 153 and 160, they both give me the same output. It's up to you which one you prefer. Sometimes, so this right now definitely seems more simple, but sometimes this can be simpler, okay? All right. Now, in these cases, we have not been specifying which columns we want, right? We have always been talking about give us all the columns. But you may just want some columns as the output. So within the subset function, there is another argument, and you can write select is equal to, and just specify whichever columns you want. So the indices basically, right? So if you specify indices as a positive number, then you'll select those. If you specify indices as a negative number, then you will deselect those. So basically, in this case, you get the third, fourth, fifth column. And in this case, you don't get the first and second column, same as here. So all of these three things, they're going to give you the same output. So if I run these three things, so sub 1, 2, 3, you see, you get petal length, petal width, species. In this also, petal length, petal width, species. And so is this one. So all these
Like
three.
it's the same by giving minus numbers also, which one I don't want.
Yes, exactly. So
In
here
that
I'm
sense.
saying
Okay.
that you give me 3, 4, 5. Here I'm saying don't give me 1, don't give me 2. Here also I'm specifying the same thing. Yes. So all the three ways, you get the same thing. And of course, so this is the way we had seen, right? This is the other way. Here also, this is where you would specify columns. Again, we are doing the same thing here also. So there are lots of ways of, so you see each of these 6 ways, it's the same way, right? There are very minor changes, but all of them are the same, right? And then there's, of course, if you don't want to specify the name, I'm sorry, if you don't want to specify the index, you can specify the name instead, right? In this example, at least. But with names, you cannot have like a minus thing. Minus names does not work. So with names, it works, but minus names don't work. It'll just give you some error. Okay. Now there is just very few things left. Okay. So what I'm going to do is there's this function in R which is split. So split a data frame using one of the columns of that data frame. So if I run this, what I get here, if you take a look here, so I get 3 categories. So dollar Setosa, there's a big data frame here. There's a dollar versicolor. There's another data frame here. And there's dollar virginica. And there's another data frame here. Does this arrangement looks familiar to you? Have we seen this before?
No idea.
Sorry, say that again.
No idea, madam.
Okay, so we've seen this when we were talking about lists, right?
Okay.
So remember lists, you have dollar something, and then there's, so of course the lists we have seen so far, they were not like this. They were element, and then we generally have always had single elements within, like it's not a data frame within a data, like no data frames within lists. But you see here, this S variable, it's a list of 3. So you see here, we have this setosa, we have this versicolor, and we have virginica. So we have this list here. Okay. Anyway, so what such a command helps us achieve is, let's say you wanted to do something different in all these 3 data frames, because, or let's say you want to save them as different Excel files, right? Whatever. So rather than copy pasting or cutting from one and pasting in another, R can just help you split these, and then you can save it separately. Okay. So since this is a list, it's a named list, and you already can see these dollar names here. So we have seen, if you want to access if you want to access elements of a list, we have this dollar symbol with us, and we also have this double square bracket option, right? So if we have S dollar versicolor, so you see we got this data frame, right? And if I write S and double square bracket 1, then also I get the same thing. I mean, whichever. Here I got the first element. There, I think it was the third element. Okay. So, and of course, this is the one that we got. We can just double check if it's a data frame. And yes, indeed, the element that you chose from the list, it is a data frame. Okay, so all of this can seem a little bit confusing initially because it's a lot of new information. But definitely try typing this on your own. You should definitely be able to do it. Okay. Now, when I wrote this thing, when I wrote what I've highlighted here, I get a data frame. Now, once I have a data frame, I can use the dollar symbol again to get the column. So let's try this. So S, if I write dollar, I get these 3 named elements, right? I can select any one of them. Now what I've got here is a data frame. So now if I write dollar again, I get the columns of that data frame. Again, I can select any one of those. Now, of course, after this, dollar does not work but now I have a vector. So I can do whatever. I can choose one or more elements, so I can just run the whole thing together. Okay. So again, so this is what we did. This is the data frame, this is the column, this is the data frame, and this is the column. This is the data frame, and this is one of the elements of the data frame. So from the small versicolor data frame, we get the 5th row, 3rd column. I get whatever this value was. All right. Okay. And now we come to this last bit. So we have seen the cbind and the rbind function earlier, right? When we have been talking about matrices. So it's pretty much the same thing here when you're talking about cbind and rbind. So let's take a few examples. There's just 1 or 2 more differences when you're dealing with data frame. So we'll try and see what's happening here. So I've specified 3 data frames. I'm calling them df1, df2, df3. Now each of them, 3 observations of 2 variables. So 3 rows, 2 variables in all of them. But one thing you need to just see here. So I'm not specifying row names for any of them. So the row names are going to be 1, 2, 3, 1, 2, 3, 1, 2, 3 in all of them. But the column names, so df1 has A and B as the column names. df2 has A and C as the column names. And df3 has A and B again. So df1 and df2 have the same column names, but df2 does not have the same column names. Okay, now we'll see why this is important. I'll just close the rest of the things. Okay. Now, let's do a C bind. So C bind is when you're placing column beside a column. So you have two columns and then you will add in two more columns, so you'll get four columns in all. So df1, df2, that should be okay. So what's going to happen here? So you see, this is what it did. You have four columns now. Okay. Now, when you're doing R bind, so you're placing one data frame below the other data frame. Now, the important thing is, so if I'm doing it, let's say for 1 and 2, so here the column is 1, A and B. Here the column is A and C. Now R will say, well, okay, I can place A below A, but how do I place C below B? So when I run this, it says error, names do not match previous names. Okay. So, but if instead I had example like 1 and 3 here, then that's going to work because they both have column names A and B. So if I run this works just fine. Okay. So what you can do is you can change column names or you can change row names if this is not matching. The only reason why this R returns it as an error is so that R is sure that if the user is actually interested in doing what it's going to do. So it's just like a, confirmation.
For C bind, it is not okay. It can be a different variable. Column name very
So
different for C
yes,
bind.
so for C bind, you're placing it side by side, right? So for C bind, row names should be same. And here the
Okay.
row names were 1, 2, 3 in all of them. If I would have had 1, 2, 3 in one of them and then let's say X, Y, Z in the other, then it would have given a problem. You give it a try. So I've specified here row names must match. Try specifying a different row name to one of the data frames. Try doing C bind and it would not work.
Okay. Okay.
All right. All right. Now, so let's again take the example of data frame 1 and 3. So now in data frame 1, you have 1, 2, and 3 and M and O as your entries in columns A and B. And then in data frame 3, you have columns A and B again. These are different values. So there is a merge function in R. Merge is behaving similar to C bind, but it will require a common column. So what it's going to do is, I'll say merge data frames 1 and 2. Okay, let's say I'm doing 1 and 2 here, not 3. Yeah, sorry. I'm doing 1 and 2. So it has A and B and this one has A and C. So you have one common column. So what I'll say is merge 1 and 2 using A column. So by A. So if I do this, now you see 1 had 1, 2, 3 in A column and 2 had 2, 3, 4. So 2 and 3 were common in both of them, right? Column A, entry 2 and 3 were common. So what it did was, in A column, it gave me 2 and 3, and then it gave me the corresponding values of B and C also, right? So 2, 3 were capital X, capital Y in the C column, so you got that. And in DF1, 2 and 3 were small and small o, so you get small and small o here. Does this thing make sense? This one? Okay, I'm assuming it makes sense. Now, here what it did, it just took the common ones. It took 2 and 3 because 2 and 3 were present in both your data frames. But what if you want all of them? Okay, you want 1 should also be there, you want 4 should also be there. So you'll just write all is equal to true. If you do that, then it's going to give you everything. But whatever it could not find, it's just going to give you any there. Right? Because see, 1 was not present in your DF2. So it does not know what to write corresponding to 1 in column C. So it's just going to give you any. And likewise, 4 was not present in DF1. So it's just going to give you NA for column B. And now you can specify if you want all the things that are present in the first one. So which is, let's call it X and Y. The first data frame is X, the second data frame is Y. So if you want to get everything which is present in the first data frame, you'll say all X is true. If you want everything that's present in the second data frame, you want all X is Y. Sorry, all Y is true. So if I do these two lines, so you see, in this case, you got 1, 2, and 3, because 1, 2, and 3 is what you had in data frame 1, the first one. And in this case, you get 2, 3, and 4 because that is what you had in the second data frame. So first data frame was called X, second data frame is called Y, just because that's how it's alphabetically arranged. So that's about it. Okay. So these are all the commands that we discussed this week. So again, we broadly talked about two things. One was the finding patterns, maybe replacing something. And then the second part basically was about data frames. I have about 4 or 5 questions for you. So let's take a look at that. All right. So I would love if you can unmute yourself and answer these questions. So what is going to be the outcome of this command? We are using the gsub function, the global substitute function. It says 8 and 12 and then the statement. So what is 8 and what is 12 here? And what's going to happen? Anybody? Do you want to give it a try?
Substitute 8 by 12.
Okay, correct. And what's going to happen here? Is there an 8 in the statement? There is no 8 in this thing, right? The third one is where it's going to replace. So it says that you substitute 8 with 12, but since there is no 8, it would not change. So B is going to be the answer. There's going to be no change here. Okay. Now this one, it's the sub function rather than the G sub. It's just sub. Okay. Now, so we know the what sub does. It's going to change the first occurrence, but maybe something which I did not make clear in the thing was first occurrence of every element. Okay. So now here we are talking about a vector, right? So this is the first element. And we'll say this is the second element, right? So it's going to change the first occurrence of every element. So in the first element, it's going to change here. It's going to change mathematics with math. And in this case, in the second occurrence, there are two occurrences. In the second element, there are two occurrences. So it's only going to change the first occurrence here. This one remains unaffected. So can you now tell me what the answer is going to be?
C.
C. Correct. Okay. All right. Now which of the following is the correct outcome? So we're taking two examples here. grep. So you are saying that find numbers between 1 and 4. And you remember the paste command we had seen in the last week? And then in one way it's without value true, and the other thing it's with value true. So first of all, let's see what the outcome of the paste command is. So can you tell me what that is? What's the outcome of this thing? So we are saying you paste sample with this vector, separating that pasting using the underscore. So what's going to be the output here of just this thing, just the paste command? Okay, so what happens here is that you'll do, so this is the first thing and this is the second thing. Now the second thing here is a vector. So just like we have seen previously, that let's say when you are multiplying 2 and you say you multiply this with 3 comma, let's say 8 comma 10. So it does with everything, right? Again, the output that you get is 6, 16, 20. So same thing, one thing with multiple things. So this thing goes with everything. So the outcome here is you'll have sample underscore 2, and then you'll have sample underscore 5, so on and so forth, until you'll have sample underscore 1. So these are going to be your 5. So the length here is going to be 5. Okay. All right. Now, so it says find number between 1 and 4. So basically, if this input, if it has 1, 2, 3, or 4 in it, you tell me the value. So now this one, if you remember, it gives you the index. And this one, of course, it says value, so it gives you the value. Now, let me anyway write this. So sample underscore 8, and then I'll have sample underscore 3, right? Now you tell me which of these has 1, 2, 3, 4. So this has 2, this has between 1, 2, 3, 4, and this has between 1, 2, 3, 4. So what is the index? So the first index is right, the fourth index is right, and the fifth index is right. So 1, 4, and 5 for this one. Does this, like, were you able to follow? Yes, no, maybe.
Is D.
Sorry, say that again.
The answer is D, you are telling?
Yes, so there are two options here, right? There are two things that we're talking about. So the first one is B is the answer. And for the second one, yes, it's going to occur in the order. So yes, so sample 2 underscore sample 3, like sample 2, sample 3, sample 1. So for this one, it's going to be this answer, right? So this is,
Okay.
all right. Okay. And then this one. So which of the following commands can be used to access the petal length of the first 5 flowers in the iris dataset? And there can be more than one correct answer here. So we just saw the iris database dataset. So petal dot length is one of the columns. If you want to access the first 5 elements of this column, which of these 5 options do you think is going to work? So hint, there are 2 correct answers here.
A and D.
A and D, that's correct. Absolutely. So just to elaborate, so when you selected iris dollar petal length, you already have a vector. So now in the square bracket, you'll just specify how many elements you want. So it's one dimensional now. And when you just wrote iris here, you're talking about a data frame, you're talking about 2-dimensional. So you have to specify before the comma which rows you want. And after the comma, you're specifying the column, right? This one is not going to work because you don't have square brackets here. And this one is not going to work because when you selected petal length, you're already talking about 1 dimension. So this thing is weird. Okay, perfect. I think this is the last question. So this, we can take a look at this data set if you want in R right now. But basically the road data set in R is just talking about some different states of US in terms of on roadways, how many drivers are there, what's the population density of that state, different things. So if, let's say, if I just ask you, let's say if this 6 rows is the only thing, in that data set. If I ask you, out of whatever you can see here, which US state has the least number of drivers? What will your answer be? Forget
Alaska.
about R. Yeah, Alaska, right? So that's the answer. Now, can you walk me through what you did mentally? What did you do without talking about R or anything? How did you
The
reach
minimum of
Alaska?
variable drivers.
Yes. So out of the whole thing, you took a look at this thing. Out of these values, you saw, okay, this is the minimum value. And then you went here, right? So basically, this is your step one, that you saw the drivers column. This is step two, where you saw the minimum. And then corresponding to that, you saw what the value here is, right? So we'll again, I'll just write this out here. So you have the road data set, sorry, data frame. From the road data frame, you want to get the drivers column. And let's say, so this is how you can access it. Then you're saying you want to find the minimum of road dollar drivers. So this is actually going to give you 11, right? This is going to give you 11. Sorry. Now, if you want to find out this row, okay, so there's a little something, it might seem complicated right now, but try to bear with me. So I'll write road. I'll write this. I want to access some rows here. So what I'll do is, no, wait. So, okay, so I'll write road and I'll write road dollar drivers is equal to this thing. Minimum of road dollar drivers. I'll put a comma and then I'll close the square bracket. And then I'm going to write row names. And then I'll write this giant curve bracket. Okay, now again, you can do this in multiple sets also. I've just done it in one line, but we'll just double check in R if this is making sense. Okay, so I did, so there is this, why do I not get the row data set here now? Hmm. Okay, I will have to see what's happening, but okay, anyway, you can give this a try even using the any of the other data sets, but this should work. I'll see why maybe the row data set is not available by default in R. Maybe it's available with some package, but nevertheless, so this is just like an extra activity. So so what you did mentally is what this thing is doing in R. So you found the minimum and you're just saying that road drivers, wherever it's minimum, you get me that row index. You're not interested in which column comes up, so you just leave it blank anyway. You get something and you say you get me the row names of that. So that should give you Alaska here. Okay. Um, but yeah, this does feel complicated initially, but you'll get used to it. Okay. Um, do we have any questions? One of you were asking me something at the beginning of this class.
Class function.
The class function. Okay. So basically the class function is just going to tell you what sort of a data there is. Right? And there is yes. So okay. Tell me again, what is your question about the class function?
So that data frame painters I'm using painters data frame.
Ha.
I want to extract the class of the school variable.
Okay. So
So I've been using any command, I'm not able to get it.
okay. I'm not sure if I can answer the question without telling you the actual answer of that assignment. Mm, so it's
I
like,
want to know how to apply the class functions on a variable.
oh, so you can just write class and within that you can just specify painter dollar the column,
Okay,
right?
okay,
Just like we've
okay,
been seeing. So just like class iris dollar zeppelin, something like this.
okay, okay, okay.
Yeah. All right. Cool. Great then. So that brings us to the end of today's class. So your deadline for this week's assignment is going to be next Wednesday. And then the next session, which is going to be for week 11, is going to be on the upcoming Friday. So 1 week from now. All right. Okay. Thank you so much for
Thank you,
joining
thank you,
in
thank you.
today's session. Yeah. I'll see you next week. Bye bye. Good night.